This conference will now be recorded.
Good morning, one and all. This is Rajesh, and our subject embedded system design. So we have come across unit 1, where we have seen the contents like introduction, definition part, embedded systems. We have differentiated with general purpose computing system. We have seen what is the history of embedded system, and we have just classified the embedded systems based upon some parameters. The next topic we cover is major application areas and purpose of embedded systems, characteristics and quality attributes of embedded systems. So this is, what is the textbook embedded systems designed by Shibu KV. This you have to follow. Okay. So our objective was to define an embedded system that we have done. Then we are seeing what is the history part. Then we have classified it. Next we'll see the applications and purposes. So we'll just refresh our previous topic. So embedded system is a unique system. It is consisting of an hardware and software, and it does a specific task. It does a specific task having a hardware and software. It does a specific task, and this embedded system is a unique system, a real-time system, a deterministic system. So the hardware is specific, the software is embedded OS and applications software. So as you know, in our day-to-day life, we are using many embedded system application oriented devices which are based digitized. Your embedded technologies are bonded into our day-to-day activities without our knowledge. We are utilizing them, their features and the comforts provided by these embedded systems, such as our household appliances like refrigerator, washing machine, air conditioner, televisions, DVD, and music systems. These embedded systems are reliable systems. They don't define an identity, and so embedded systems are unique systems having an hardware and software and does a specific applications. They are becoming an inevitable products in all the fields like household appliances, telecommunications, medical equipment, industrial controller, consumer products. So we have defined it. Embedded system is an electromechanical system doing a specific function, having hardware and software. So it is a combination of hardware and software. They run on their own without human intervention, and they operate in real time. So these are some of the examples of an embedded system, like our digital camera, microwave oven, car automation system, refrigerators, electronic toys, satellite system, navigation systems, smartphones, DVD players, washing machines, metro rail, air traffic controllers, and your ECG. So these all are having, these are the products of embedded system. So they are having hardware and software, and they are doing a specific task. So they can be a single system or they can be a part of a big system, and they are unique. So this embedded system is having three components: hardware, application software, and real-time OS. This real-time OS is going to control the way application software is designed by the manufacturer, and this RTOS is going to control, it is just going to define the way the system will work. So we have seen our embedded system is differentiated with general purpose computing system. Your embedded system is application specific. It is tailored to take advantage of power saving techniques. It is a real-time deterministic system. So classifications you have seen based upon the generation, complexity, and performance, based on the deterministic behavior, based on the triggering. They are classified into different categories. So based on the generation, there are four types: first generation, second generation, third generation, and fourth generation. Based on the complexity and performance, they are small scale, medium scale, and large scale. Based on deterministic behavior, they are soft and hard real-time systems. Based on the triggering, they are event triggered and time triggered. So this all topics were covered in our previous class. So you just go through them. Our topic for this class is purpose of embedded system. So we'll go first applications. The applications of embedded system is they are countless and various products are used in consumer electronics such as camcorders, cameras, household appliances such as washing machine, refrigerator, automotive industry such as anti-lock braking system, engine control, home automation and security systems such as air conditioning systems, sprinklers, fire alarms, telecom systems such as cellular phones, telephone switches, computer peripherals, it is printers and scanners. See, the first heading is a classification. It is a area. Like computer networking system is one area where a large number of embedded systems are available. Among them, network routers and switches are one. Similarly, healthcare systems. Under healthcare area, we are covering EEG and ECG as our examples for embedded system. Similarly, banking and retail, we are having ATM machines and point of scales. Under card readers, we are having barcodes and smart card readers. What is a barcode reader? Smart code reader in ATM machines we are using in bar. So the ATM machine used is it will also monitor the transactions, whereas barcode smart code will only authenticate that you are a specific person or it is a designed for it is because in televisions also when you go for using smart barcode we can give authentication of the person. So these are the various applications, and from our discussion we can say that these embedded systems are inevitable products used in all the areas such as the 10 above which we covered: consumer electronics, household appliances, automotive industry, home automation, security, telecom, computer peripherals, computer networking system, healthcare system, banking and retail, and card readers. These are the major areas of our embedded systems. So here we comes our purpose of embedded system. So this is our purpose of embedded system. So today topic. So as I know, everyone know what is an embedded system. Embedded system is a unique system having a hardware and software and real-time OS. This real-time OS is going to define how the system operates as per the application software provided to it, and this hardware is the core of the embedded system. This core is having some peripherals, inputs and outputs. It is going to sense the data, and based on the sensing the data, it converts into a digital form, it saves in the memory, and this processor reads the memory contents as per the application software stored in the ROM. It does the applications and finally it gives the output to the actuator. So embedded system is a unique system. It is a real-time system. It is a deterministic system. All the time it may not be deterministic, but compared to general purpose, it is realistic. So how it is how it does so many activities is there is a purpose of embedded system. Embedded system is not a single system. It is a combination of systems. It has some inputs, outputs. It has some memory. It has some hardware. It has some operating system. And the key element of an operating system for a real-time operating system is the kernel. So this kernel is going to do task scheduling and task sharing. Based on that, we are going to perform this logic of task scheduling and task priority, and your input data. Any application you can take refrigerator, you can take air conditioner, you can take washing machine, you can take elevator, you can take any robots. So every embedded system, first it has to take the input, and that is done by a sensor or a keypad or a buzzer or any physical quantity. It has to take it. So that taking that is given to the embedded system. So that is our purpose. The purpose of embedded system is each embedded system is designed to serve the purpose of any one of these combinations. So first it has to do the data collection. So data collection, data storage, data representation. So these are the three things. Data we have to collect it, data we have to store it, data again we have to represent it. How you represent? The collected data can be an analog one, the collected data can be a textual one, the collected data can be an image, but you cannot store the same data in the same form. So you have to store by converting into another form, such as giving it to an converting it to an electrical signal. That electrical signal is again converted to a digital signal. That digital signal is stored, and that is also represented in a proper way to a processor. So the next part we have to do is data communication. So all the time embedded system may not having peripherals connected to it. Some embedded systems may have peripherals connected in a remote area. So that remote area data communication must be done, and data collection must be sent to your embedded system using data communication. So whatever the data you get, that must be processed as per your logic. So that is called data signal processing. Next, so we have to monitor it. You have to monitor the data. Then we have to do the controlling part. Then you have to use this application specific user interface. So these are the 6 areas which are utilized to for better performance of your embedded system, without which your embedded system purpose will not be solved. So embedded system purpose is it has to perform a specific task by taking input. It has to do so many tasks provided by the application software written by the manufacturer. The end user can only utilize it. A washing machine, the end user can only use it. A refrigerator, the end user can only use it. But the program written is called application software. But what the RTOS is doing, RTOS is going to just monitor the program application software, whether it is occurring as per the application software or not, whether the events occurring are as per the application software or not. And we told this RTOS is real time because in some applications it is real time and deterministic. Some applications it may have slight deficiency. That's why the real time systems are classified into 2 types: hardware and hard and soft. So the hard real time systems, soft real time systems, they are deterministic systems and they are unique systems. So here embedded system is serving the purpose by doing the 6 tasks. So what is this data collection, storage and representation? Embedded system designed for the purpose of data collection, performing acquisition of data from the external world. So your embedded system placed at some remote area must do first data collection, or embedded system such as your air conditioner placed in a room must do first data collection, or placed in a military application. So all the thing is it has to acquire the data from the external world. So what it does, next what it does, this data collection is usually done for storage, analysis and transmission. A digital camera will capture the image, but it gives the image to a equipment available at a remote area by wired or wireless methods. So data collection is usually done for storing, for doing analysis and for transmission, and your collected data can be an analog or digital one. So your data collection is done from the external world. This data collected is used for storing or for analysis or also for transmission, and the data collected can be an analog one or digital one. So the first purpose of embedded system is data collection, storage and representation. Embedded systems with analog data capturing techniques collect data in the form of analog signals, while systems with digital data mechanism collect the data in digital form using A to D converters. If the data is digital, if the data is digital, it is captured by the embedded system, digital embedded systems. So there are digital systems. So those digital systems will capture directly the digital system. If there is an analog embedded system, it will capture the analog signal, then it will digitize it. So like that, embedded systems can be designed to directly collect the analog data or directly collect the digital data. So the example under this data collection is what is the data collection for air AC air conditioners? For air conditioners, data collection is room temperature set by the end user. I want my room temperature to be set by to 22 degrees. What the air conditioner will do by using a sensor, it senses the room temperature as 38 degrees, and based upon the 38 degrees sensed and sense that temperature set by the user, it calculates the difference, and it will using with the help of a processor or the program written, it will actuate the motors to run, and this airflow is given into the room such that cooling is done, and your 38 degrees is made to 22. Once the difference matches, it will stop the motor. So here the data collected is a input one given by the user in a digital form on a keypad on the remote. But if you see some other example, data is a different. So like your digital camera, this digital camera is one example for data collection, storage and representation. It is capturing the image, and this is represented on a LCD screen using a graphic LCD unit. So data collection, storage and representation purpose is to collect the data for storage, analysis and transmission, and the collected data can be an analog one or digital one. The second purpose of embedded system is data communication. See, whatever the data is collected, you may require to be sent to a remote area available in some other uh, country. So in such a way, you have to do the transmission using satellites, or within house, it is a home networking system, and you require the data to be transmitted in lined one or wireless methods, and the data transmitted can be an analog one or digital one. See, you can convert, you can transfer the analog signal, then the receiver received person can digitize it, then you can give to a embedded system placed in a remote area. It will take the analog image or analog signals, uh, then or it may be a textual image, or it can be a textual code, or it can be a image, then it will convert to into the required format. So first is data communication. Whatever you transmit, either analog or digital or text or image, you have to communicate. So there must be, first it is captured at one place, and that is transferred to a remote area placed embedded system. So an embedded system placed in a remote area, any other specific area, so that is data communication. So for this we are using a communication method. So you are having wireless modes. Wireless means without any wire you can transfer the data using Wi-Fi and Bluetooth techniques, and you can also use wireline modes. What is wireline mode? Your digital camera, which is coming under data storage, data collection, data storage and data representation, that will capture the image and send it to a embedded system using a wireline module such as USB or TCP/IP protocol, or any RS-232 bus, like that. So wireline modules are USB, TCP/IP, network hubs, routers, switches. They are used for data transmissions. What is data signal processing? So as we told, this data collected is only the information. We have to process it to know, like speech is there. So you have to analyze the speech, identify what is in the speech. Based on that, the embedded system must react, give an output, audio, video. So for that, we have to go for signal processing. So example is digital hearing aid is a typical example for an embedded systems employed for data processing. So a digital hearing aid improves the hearing of a hearing impaired person. So a hearing impaired person will not be able to listen directly. So a digital hearing aid placed to his ear will detect small signals, it will amplify it, it will modify, it will modulate such that it is audible to the user. So this data signal processing means internal logic of a digital hearing aid. Purpose is it will collect the data. It is going to transfer the data by using data collection. Then it is going to do processing the data such that it is audible to the person. Then next embedded purpose is monitoring. All embedded products coming under medical domain are will come under the classification of monitoring, such as electrocardiogram. It is used for knowing the heartbeat of a machine. It cannot control, but it can just identify what is the heartbeat of a patient. And some other monitoring systems are digital CROs, digital multimeters, and logic analyzers. So these all will come under monitoring. Another one is the control. A system with control functionality contains both sensors and actuators. Sensors are connected to the input ports for capturing the changes in the environment variable. So what is the purpose of a sensor? An input port is having a sensor connected to it. This input port captures the changes in the environment variable, and the actuator connected to the output port is controls the changes in the input variable. So air conditioned system used to control the temperature to a specific limit. So this comes under control application. So under control purpose of embedded system, the control application is met by air conditioned system, where we are going to sense the input temperature from the sensors connected to the input port, and they are based upon the change in the temperature, we are going to give a data to your output port. Application specific user interface. So another purpose of your embedded system is application specific user interface. This application specific user interface is using buttons, switches, keypads, lights, bells, displays, and our mobile phone comes under example for application specific user interface. In mobile phone, the user interface is provided with a keypad, system speaker, vibration alert. So these are the purposes of embedded system. So just we'll go through what we have studied. So embedded system is a unique system. It is a combination of hardware and software. It may or may not have OS. It is real time, deterministic. It is an electromechanical system serving the purpose of a specific function, and it is a unique, and all the inevitable products this embedded system logic is used. So these are the examples of embedded systems, and it is having a hardware where we are having software embedded in it. It can be a single system or it can be a part of a big system. Now because there is a more processors are available, you can use it as a microcontroller or a microprocessor based real-time system doing a specific task. It has three parts. One is hardware, application software, and real-time OS. It has a sensor, A to D converter, processor, D to A converter, and actuator. These are the examples of the embedded systems. We have just compared embedded system with general purpose computing system. It is having a special purpose hardware and embedded OS. It may or may not contain the OS for functioning, and the software is pre-programmed by the manufacturer. It tailors for power saving modes. It is real time and it is deterministic. So these are the various classifications based upon the generation, complexity, and performance, based on the deterministic behavior, based on the triggering. So based upon the classific generation, it is first generation, second generation, third generation, fourth generation. Based upon the complexity and performance, it is small scale, medium scale, and large scale. Based on the deterministic behavior, it is real time. Again, it is classified as hard real time and soft real time. Based on the triggering, it is event triggered or time triggered. So these are the application areas such as TV, stereo, remote control, phone, mobile phone, refrigerator, microwave, washing machine, oven, electronic, musical instruments, toys. And coming to our topic, purpose of embedded system. This embedded system is designed to serve the purpose, and this is classified into 6 types. Data collection, so how you collect the data, how you store a data, how you represent the data, and this must be communicated to a transmitted, that is done by a purpose called data communication. Another purpose is data signal processing. Next is monitoring. Next is control. Next is application specific user interface. So the purpose of embedded system is met by combination of the following tasks: data collection, storage, and representation. Can be an analog data or digital data, and collected data can be stored in either form, and example is our digital camera. Data communication must be done to a remote area by either wired or wireless methods, and data signal processing is done by a digital hearing aid, and a monitoring application, so like our medical applications we are using ECG and various other equipment. Next, control application like air condition systems, we are using air conditioning system to control the room temperature, and application specific user interface comes under the peripherals which are used to control the embedded system. So this, with this topic I'm stopping here. We'll cover one more topic in our coming class. So we'll stop with this. Okay.